Alright, this video is a quick review from section 4.9, and you should pause the video and work through these. And I'm sorry, I should give you some directions. How about let's start there. So the directions here would be to graph the quadratic inequalities. So, see how you do. Alright, so the first one's in standard form, and I'm going to circle this one in blue, so everything I do in blue will revolve around this first one. So if it's in standard form, I'm going to find the vertex by using the opposite of b divided by 2a to find the x-coordinate. So that would be a negative 2 divided by 2 times negative 1. So negative 2 divided by negative 2 is positive 1. So the vertex is going to be 1 something. And then I'm going to plug in 1 for all of the x's. So I'm going to get negative 1 plus 2 plus 3, so that's going to equal 4. So my vertex is 1, 4. So if I go over to 1, 4, and I'll plot a point there, and I know my pattern of change for this one is going to be a is negative 1, so it's going to be a negative 1, negative 3, negative 5. So I'm going to go over from my vertex, I'm going to go over 1, down 1, over 1, down 3, over 1, down 5, and from my vertex I'll go the other way, down 1, over 1, down 1, over 1, down 3, over 1, down 5. And then because there's no equal sign underneath that inequality, I know it's a dashed parabola, and that's the easiest thing to forget, so just try to remember that when you take your test. The second quadratic I'll do in red, and that one's also in standard form, but nice and easy because there is no b, so the opposite of b divided by 2a is just going to be 0, and if I plug 0 in for the x's, I'm going to get negative 1. So 0, negative 1, and then my pattern of change is a times 1, 3, 5, so it's going to be 2, 6, 10. So I'm going to go over 1, up 2, over 1, up 1, 2, 3, 4, 5, 6, and I won't go 10 because I'll be off my graph, and then the other way over 1, up 2, over 1, up 6, and that one is a solid parabola because the equal sign underneath it. And then I'm going to go back and shade. So I'll start with my red one actually, since I'm there. You might be fine with the fact that if it's greater than, I'm going to shade inside that parabola. If not, test a point, and I can test the origin because my parabola is not going through it. So if I test 0, 0, I get is 0 greater than or equal to negative 1. And yes, it is, so I want to include 0, which if I shade inside that red parabola, I would be including 0, so that's good. For my blue one, it's opening down, and it's less than, so you might be okay with the fact that it's everything inside. Again, if not, test 0, 0. So if I put 0 in for y and 0 in for x, I get is 0 less than 3, and yes it is, so I want to shade everything inside so that I include 0. And then your shaded region would be everything in which the two shadings meet. So since they're both inside, it would be just that area. Alright, this one says solve algebraically, so pause the video, see how you do. When you solve something algebraically, note that there's no y in these equations, so we really want to find out where x is larger than 0, and I guess I can start there. Of course, I'd want to get everything on one side, so I'll add the 14, and I want to know what x values are going to make this quantity larger than 0. So if you think about this, and I'm not actually going to graph it, but you know, a parabola opening up, and I really just made this up, it might not look anything like this, but if you shaded it on the outside, then it would be all the x values that are less than this point and greater than that point. If I shaded the parabola on the inside, then it would be all the x values greater than that point but less than that point. So you could actually graph this like I did on the first slide and then tell me those x values that are in the shaded region. But it might be easier because graphing, you know, it takes a while to actually solve this. So if it's factorable, and this one happens to be x minus 2 times x minus 7. Oops, I don't want an equal sign, sorry. And then if I solve those, I'm just going to ignore the inequality. I just want to figure out what these critical points are right there. So if I solve it, I'm going to get x equals positive 2 and x equals positive 7. Okay, so now let me redraw a graph that's a little more accurate, right? So here's 2 and here's 7, and I know it's opening up, you know, I totally missed 7, didn't I? Let's just adjust. There's 7. So I know that it's either going to be everything in between 2 and 7 if it were shaded here, or be everything less than 2 but greater than 7 if it were shaded on the outside. Well, how do I figure that out? Well, I test a point. So if I tested 0, just because it's so easy, so here's 0, let's see what happens. And I'd go back up to the original just to be safe. So 0 squared minus 9 times 0, is that greater than negative 14? So that's 0. Is 0 greater than negative 14? And yes, it is. So I want to shade towards 0 because it worked. Well, then nothing between 2 and 7 should work. You could test something if you want. You could also test, 8 maybe. So let's just do that. If I did 8 squared minus 9 times 8 should be greater than negative 14. And that's 64 minus 72. And yes, that is greater than negative 14. So I know I want to go here. So my final answer is x is less than, I keep putting equal signs under there, sorry. X is less than 2, or x is greater than 7. If you had tested those points and they did not work, then you would know it's everything in between it. So x is less than 7 but greater than 2.